Howdy, folks. Welcome to Chapter 14. This is the Autonomic Nervous System, and it's an overview. Let's see if our pen works. It does. So we have, in covering the entire nervous system, we've looked at the central nervous system. We've looked at the peripheral nervous system. So CNS was Chapter 12. Peripheral nervous system is Chapter 13. And the autonomic nervous system here is Chapter 14. So for the autonomic nervous system, I'm going to call the two divisions of the autonomic nervous system are the sympathetic and parasympathetic. And I'm going to call the sympathetic division the SNS, and I'm going to call the parasympathetic division the PNS. And that can get a little confusing when I'm talking about the peripheral nervous system and the parasympathetic nervous system. I think I spell the words out, but for this chapter, parasympathetic will be PNS. So the autonomic nervous system consists of, and it says here, visceral motor efferent neurons. So we're over here. Here's the motor efferent division. Somatic system is here, so that every time you hear somatic, you think muscle, skin, and joints. The other aspect of the motor efferent division is the autonomic nervous system. And the autonomic nervous system serves the viscera. So remember, the viscera are like your heart, your lungs, stomach, intestine, etc. Here it says the visceral motor efferent neurons of the autonomic nervous system will innervate smooth muscle, cardiac muscle, and glands, but no skeletal muscle. Remember, the somatic nervous system innervates skeletal muscle. The autonomic nervous system operates via subconscious control. So that means, unless you're a guru living on Mount Everest and can control all your viscera, then for most of us, the autonomic nervous system is operating via subconscious control. Autonomic nervous system is also called the involuntary nervous system because you can't consciously and voluntarily work the autonomic nervous system like you can consciously control your skeletal muscle. So this gets a little tricky. They say that the autonomic nervous system is a visceral motor system, but there is also a visceral sensory component. So it depends on the book that you're using, but for us, the autonomic nervous system has sensory afferent neurons in it and motor efferent neurons in it, going to and coming from the viscera. So now we're just going to briefly look at the difference between the somatic system. So remember, that's skeletal muscles, joints, and skin. So that shows it in this cartoon here. There's flexing your bicep. Versus the autonomic nervous system. So the autonomic nervous system is this bottom panel. So let's look at the top cartoon, which is a cartoon illustrating the somatic nervous system. So this, for example, this could be a somatic motor efferent neuron. So here's the cell body, here's the dendrites, here's the axon with the myelinated, well, it's actually a myelinated axon. Here's the axon terminal. Here's the neurotransmitter that's released onto the target organ, which is skeletal muscle. So hopefully this cartoon will remind you of the neuromuscular junction. So do you remember the neurotransmitter that was released from the axon terminal in the neuromuscular junction? If you said acetylcholine, bingo, you got it. So this is, the top panel is the somatic nervous system. And then the autonomic nervous system is the bottom panel here. So let's take a look. So here is a autonomic nervous system neuron, and this would be these would be cartoons of the motor arm of the autonomic nervous system, because you can see that the effectors, or the viscera, will result in this motor efferent information telling the smooth muscle cells, basically, and the cardiac muscle cells what to do. So in this top panel, so here's the cell body of a autonomic or visceral motor efferent neuron. Here's the axon. It's releasing a neurotransmitter. We'll talk more about that later, what that is. But it's releasing a neurotransmitter onto a second neuron. So you can see in the somatic nervous system, there's just one neuron going out to the target or the effector organ. In the autonomic nervous system, it's a 2-neuron chain. So here's our first neuron. And I don't know if I'm sure you remember that the definition of a ganglia. So a ganglia is a collection of cell bodies in the peripheral nervous system, and that's what this yellow thing is. This is a ganglia. So what's happening in the ganglia is the axon terminal is synapsing with this second neuron in the chain, and then that second neuron will fire an action potential, have a bunch of biochemistry, releases a neurotransmitter, and binds to a target in the viscera. So if this yellow thing is a ganglia, then what they do is they call the first neuron that comes into the ganglia, they call that the pre-ganglionic neuron. So that's pre-ganglionic neuron. And if they call this guy the pre-ganglionic neuron, what do they call the second neuron? If you said post-ganglionic neuron, you would be right. Sorry, this writing is so terrible, but I'm writing with a mouse. So the second panel, here's another neuron. But this time, this neuron is not synapsing with a post-ganglionic neuron. This is not a ganglia. This is actually the adrenal medulla, this piece of tissue. So in this cartoon, and this is part of the sympathetic nervous system, but this neuron releases a neurotransmitter onto the adrenal medulla, and then it releases its neurotransmitter into the blood, and it can travel everywhere and bind to any of these target organs. And then the third panel, here's our first neuron. Here's a ganglia, so instead of calling it the first neuron, we can call it a preganglionic neuron. Releases a neurotransmitter, the postganglionic neuron binds to it, it sends an action potential and releases its neurotransmitter, and then that neurotransmitter can bind to any of these target organs. So the two systems, somatic versus the autonomic nervous system, they differ in their target organs. So the somatic nervous system target organs in this cartoon is skeletal muscle. The two systems differ in their, in other words, the two systems differ in their effectors and how they're innervated. The two systems, somatic versus autonomic, differ in their motor efferent pathways and their neurotransmitters. So it's not a big difference. The neurotransmitter in the somatic nervous system is acetylcholine, and the first neurotransmitter that's released here in the ganglion is also acetylcholine. They'll have different receptors, though, responses to neurotransmitters. So we'll talk more about this later, but this neurotransmitter in the somatic nervous system is acetylcholine. This neurotransmitter is also acetylcholine, but these two acetylcholines will have different receptors, so there'll be a different effect. Somatic nervous system effectors are skeletal muscles mostly. Autonomic nervous system effectors are cardiac muscle, smooth muscle, which completely lines your intestines and your intestines and your stomach and your bladder and your smooth muscle also plays a role in the glands, because if you want your glands to squirt out their juice, you have to have smooth muscle. Okay. In the somatic nervous system, I already said this, there's only one neuron to get to release its neurotransmitter on the effector. In the somatic pathway, these are heavily myelinated axons, and you can see in the cartoon even, like, look at how many times this Schwann cell wrapped around to make the myelin sheath. So in the autonomic nervous system, like I said earlier, it's a 2-neuron chain, except in the case of the adrenal medulla. It's a 2-neuron chain. The preganglionic neuron, so we called that, here's the preganglionic neuron of this first panel. It has a thin axon and it's lightly myelinated. How would you like your myelination? I would like my myelination lightly myelinated, please, and that's what you get in the autonomic nervous system versus heavily myelinated in the somatic nervous system. The postganglionic neuron is unmyelinated. So check it out. Here's a postganglionic neuron in this. There's no Schwann cells wrapping around the axon, so there's no myelination. And in this bottom panel, there's no myelination in that postganglionic neuron. Okay. Now, what I did is I added the neurotransmitters in the cartoon. So we already talked about this in the somatic nervous system. The neurotransmitter that's released from the axon terminal to the skeletal muscle is acetylcholine. And now I'm also telling you that these top 2 panels are illustrative of neurons in the sympathetic nervous system, and this bottom panel is how the parasympathetic nervous system operates. So let's look at the neurotransmitter in the sympathetic division. So in the ganglion, and also the neurotransmitter that's released at the adrenal medulla is acetylcholine, but the postganglionic neuron releases norepinephrine. And then the adrenal medulla, which is kind of like a postganglionic neuron, will release epinephrine and norepinephrine into the bloodstream. That's what these little balls are, epinephrine and norepinephrine. So the sympathetic, you have 2 ways to get the information, your motor efferent information, out to your effectors. In the parasympathetic, there's just one method. They use a preganglionic neuron that's lightly myelinated. In the ganglion itself, the neurotransmitter that's released from the preganglionic neuron that binds to the postganglionic neuron is called acetylcholine. You've seen that. But then the postganglionic neuron also releases acetylcholine. Now what we'll see later is these 2 acetylcholines, the one from the preganglionic neuron versus the one from the postganglionic neuron, those acetylcholine will bind to different acetylcholine receptors. So they'll have different effects. So let's take a look at the stats. The autonomic nervous system, the axonal endings of the preganglionic fibers release acetylcholine. We said that. So these guys are all preganglionic neurons, and they all release acetylcholine. The axons of the postganglionic fibers release norepinephrine. So here's our in the sympathetic nervous system. So postganglionic, here's our postganglionic fiber or axon releasing norepinephrine in the sympathetic nervous system. The postganglionic neuron in the parasympathetic nervous system releases acetylcholine. And then our third check mark down here, it says the effect on these target organs is either stimulatory or inhibitory. depending on the type of receptor present on the target organ. So for example, with acetylcholine in the somatic nervous system, the effect is always stimulatory. With norepinephrine or acetylcholine being released on these targets, the effect could be stimulatory or inhibitory, depending on the type of receptor. Oh, and I just said this check mark down here. It says all somatic motor efferent neurons release acetylcholine. So that's the top panel. So here's the whole cartoon that puts it together. So let's take a look at the left side. So this is the somatic nervous system. It goes to the skeletal muscle. Here's the autonomic nervous system with its two branches, the parasympathetic nervous system and the sympathetic nervous system. And the parasympathetic and sympathetic nervous system have preganglionic neurons and postganglionic neurons, but the sympathetic nervous system also has this system where that first neuron innervates the adrenal medulla, and then the adrenal medulla acts like a postganglionic neuron and releases epinephrine and norepinephrine into the blood. So one other thing, let's take a look at these check marks down here. It says the sympathetic nervous system has, so we're up here, has short preganglionic fibers. So short preganglionic fibers. And then they have really long postganglionic fibers or axons, whereas the parasympathetic nervous system is opposite. So it kind of shows this in this cartoon, not really well, but it kind of does. The parasympathetic nervous system down here has really long preganglionic fibers or axons, and parasympathetic has short postganglionic fibers. I think that's it. Nope, it's not. Oops. So here's a cartoon of the parasympathetic and sympathetic nervous system. So this side, the left side of the cartoon, is the parasympathetic innervation, and the right side is the sympathetic innervation. And I said this on the last slide, but I think this cartoon illustrates the concept better. So the sympathetic nervous system, which is over here, has really short preganglionic fibers, so you can see how short they are. And then they have really long postganglionic fibers, whereas the parasympathetic nervous system has really long preganglionic fibers. So you can see here, here's a really long preganglionic fiber. Here's the ganglia, and then look at this, just this little bit right here. That's the axon or the fiber of the postganglionic neuron. So the sympathetic division, people say it's the 4 Fs. Well, some people say it's the 3 Fs. I like to say it's the 4 Fs. Fight, flight, freeze, and some people say the 4th F in the sympathetic nervous system is, well, I'll just say fornication. So that sounds, but you know what I'm saying. There's 4 Fs. Sympathetic division is also called the thoracolumbar division because these preganglionic fibers exit from the thoracic and lumbar regions of the spinal cord. So this is all thoracic and lumbar region of the spinal cord. So it's called thoracolumbar. Parasympathetic division, over here on the left, is the rest and digest division. And it's also called the craniosacral division because look, the parasympathetic preganglionic neurons come from the area of the cranium and down here in the sacrum, and nothing from the cervical or thoracic region. So, and I think there's some kind of therapy, like a massage or relaxation therapy called craniosacral therapy, where they massage those areas. But you know, they're trying to activate parasympathetic division so you can relax or rest. There's dual innervation of effectors by both the sympathetic and the parasympathetic nervous system. So for example, both the parasympathetic and sympathetic nervous system innervate the eye. And we'll look at that in more detail when we look at the parasympathetic and sympathetic